Linear relationships are the most common ones. So we've got an example. Say you're going to work for a conference and you drive your own car. You can claim back the money that you use for your vehicle, and I checked it, it's at the moment 45 pence a mile. So say you travelled for 30 miles and you're claiming back at 45 pence, that comes to £13.50. So what we have here is 30 miles, standard cost per mile, and here's the cost. So you can write that in words. That's the number of miles, pence per mile, and the claim amount. So you can write that even more symbolically or condensed. So that's number of miles times the cost per mile comes out to the claim amount. So what we've got here is our two variables. If we change the number of miles that we travel, then that's going to change the amount that we can claim back. So number of miles and the claim amount are variables. So one way to think about a relationship or to investigate it is looking at numbers or data. So we plug in numbers into the variables so that we can get an idea of the relationship. Let me show you what I mean. Here we've got the number of miles, M, and here's the claim amount. Okay, well, say we go for 1 mile, so that's one lot of 0.45, so that's 45 pence we get out. If we go for 2 miles, it's 2 lots of 45 pence. 3 miles, 3 lots of 45 pence, and on. So we get some bigger numbers. So we go for 10 miles, a whole £4.50, 20 miles, £9. So one of the things we notice here is the gap in the numbers. Obviously, every time we go an extra mile, so the number of miles increases by 1, what we see is the amount we can claim increases by 45 pence. So each time we increase the number of miles, the claim goes up by the same amount. It goes up by the same amount each time. Another way to think about a relationship is graphically. So we plot one variable against the other. So say here we have number of miles, which is M, and our claim amount, which is C. So we'll go up in ones, 1 mile, 2 mile, 3 miles. I think we'll go up in pounds, £1, 2. So if we go 1 mile, we get to claim 45 cents, 2 miles, 90 cents, 3 miles, 135 around there, 4, 180, 5, 2, 25, something like that. So what these make is a linear relationship. If we go no miles, then we make no claim. So we also go through 0, 0. And depending on how well I've plotted it, these join up with a nice straight line. So when we're looking at this, key features of the graph line up with key features in the equation. So let's look about what's changing. So every time we go an extra mile, the claim increases by 45 cents. Extra mile, claim increases by 45 cents. Mile, 45 cents. So this bit here is 45 pence. Pence, not cents. We're going to play a little game of what if now. Now, what if, instead of it being 45 pence for a mile, say we could claim a whopping £1.50. Then for each mile, we could claim £1.50, and that would work out the claim amount. So I'm just going to get some data together. This is the number of miles and the cost. So if I go no miles, claim nothing. 1 mile, £1.50. 2 miles, £3. 3 miles, £4.50. 4 miles, 6. So let's see what that looks like on the graph. So I'll do it in blue again. So it still goes through 0, 0. 1 mile is £1.50. 2 miles, £3. 3, £4.50. 4, up to 6. So what we've got here is we've got a much steeper line because there's a much steeper rate of change, because for every mile that we travel, we're now going up £1.50. For every mile, we're going up £1.50. So there's our £1.50 there. So we can see that here in the equation. Every time the mile's going up by 1, we're getting £1.50 more for our claim. So what's happening is this part of the graph, this part of the equation is actually making the graph more steep. I've got one more what if. What if our glorious employer was wanting to reward us for using our own car? So there was a little bit of an incentive scheme going on. So they were going to actually give you £3 just for having used your own car. And then they were also going to give you £1.50 per mile, and that would come to the claim amount. So if we investigate this data, number of miles, cost for the claim amount. So this time for going, technically if we went no miles at all, but we put in our claim form, then we would get £3. If we went 1 mile, then we would get the £3 plus the £1.50, which would come to £4.50. So if we plot this one on the graph, then it's a little bit hypothetical, but hypothetically, if we'd gone no miles, we could still claim £3. We know you couldn't really put a claim in if you hadn't done it, but that's where maths meets the real world. Hypothetically, that would be the case. So then once we've gone 1 mile, we're up to £4.50, 2 miles, so there's our straight line there. So what you'll notice is that the steepness, the rate of change of our last graph and this graph is exactly the same. That's because we're still getting £1.50 for every mile, so the steepness is the same. However, you can see that our brown graph is jumped up, and that's because we've got this initial flat fee, if you like, this claim number of 3. So we're starting our adventures, as it were, from 3. So we'll just recap. We've got £1.50 per mile comes to the cost. I'm just going to write that another way. Cost is the same as 1.5 lots of M plus the £3 incentive. So it's just the same as what we had before, but just turn the equation around. Now how we can summarise it is that this part here is controlling the rate of change of the graph. So if this one is larger, then what we get is we get a steeper graph. This part here is controlling the flat fee, or where we start, or what the value at 0. So this value over here is causing the graph to cross over the 0 axis, cross over the axis at 0 at different points. Now this is the form of any linear equation. So you'll have seen it in the form y equals mx plus c. So what we've got here are our two variables. So for us, the variables were the number of miles and the total cost. This part here is called the gradient, and it's normally just a number, and it's what's controlling the gradient of the graph, or the rate of change. This one here is called the constant, and it's the value at this point where the graph crosses the vertical axis. All linear equations are a version of this. So for example, it might be some variable with a gradient of 2.3, rate of change of 2.3, and it crosses the vertical axis at 12.